Okay, let's finish up the part that we had started on Friday in the curious electromagnetic detour. So we already said that we knew mu O was 4 pi times 10 to the negative 7 Tesla meters per amp, and that it has a counterpart in material of just mu. These are so it's the permeability. This one of free space, this one of other material. The how well the magnetic field travels through that material, whether it's empty space or a ferromagnetic material or plastic or whatever. Okay, so that's in magnetism. What I haven't told you to this point, even those of you that have taken Physics 12, is that there's also an epsilon O. So epsilon's another Greek letter. And epsilon O is called the permittivity of free space. Permittivity, permittivity of free space. And it's how well an electric field travels through empty space. It also has a counterpart, epsilon, in the other materials. Now, if you remember from electrostatics, we had the equation FQ is equal to K Q1 Q2 over R squared. Well, it's confession time for me because this K is a constant that we use to simplify the real constant. This equation is really 1 over 4 pi epsilon O QQ over R squared. But people didn't really like this yucky constant and said 4's a constant, pi's a constant, epsilon's a constant, why the heck can't we just put them together and call it K? So we did, but then we can find then the value for epsilon because it's just going to be equal to, right, if we set over here K equal to 1 over 4 pi epsilon O, bring the epsilon up, bring the K down, 1 over 4 pi K. So 1 over 4 pi, and the real value for K, we used it rounded in physics, but the real value is 8.988 times 10 to the ninth, and it's the positive 9, not the negative 9, so it's 10 to the ninth, and its units are Newton meters squared per Coulomb squared. And so if you type this in your calculator, so take a second and do it. You could pause me. Take a second and do it. All right, did you do it? If you did, you should have gotten 8.853746278 times 10 to the negative 12. And the units will just be Newton per meter squared per Newton meter squared per Coulomb squared flipped. So Coulomb squared over Newton meter squared. Okay, so this is the value for epsilon O. All right, so we have a value for mu O and we have a value for epsilon O. So there was a guy, his name was James Maxwell, and some of you maybe have heard of him. And James Maxwell was around as people found that a current carrying wire created a magnetic field, and that people found a changing magnetic field created a current in a wire. And he knew that a current in a wire had an electric field around it, and he knew that then the current carrying wire created a magnetic field. And he thought, these fields always seem to show up at the same time. And it's like they're always together. So perhaps this mu O and this epsilon O have some kind of significance that we should be looking at. And so he multiplied mu O by epsilon O. And just to simplify our lives, so he did, remember, 4 pi times 10 to the negative 7 Tesla meters per amp. And he multiplied that by, and I'm going to write it with the K just to make our lives easier, 1 over 4 pi K. And I say to make our lives easier because the 4 pi will cancel, right? So you'll just have 1 to the negative 7 divided by the K. So you'll have 1 times 10 to the negative 7 Tesla meters per amp divided by 8.988 to the 9th Newton meters squared per Coulomb squared. Okay, so pause me again and find out what this value is. Okay. Did you do it? All right, if you did, you should get let me put it in scientific notation, 1.129465391 times 10 to the negative 17. That really doesn't look like a number that I recognize. How about you? But you know what? We didn't do the units. So we need to do the units. So don't cheat. Pause this and see if you can get the units. And so it's going to be Tesla meters over amps divided by Newton meters squared per Coulomb squared. So maybe the units will tell us something. So pause this for a second and see if you can figure out the units. All right, did you pause me? So if you did, you might already know what's up. So flip and multiply Newton meters squared. So 1 meter is going to cancel. And so you're going to have Tesla Coulomb squared over an amp Newton meter. Now don't be too quick to change too much too soon. I would probably change the Newton. So from F equals BIL sine theta, we know B is equal to F over IL. So we know a Tesla is equal to a Newton over an amp meter. So down here where a Tesla is, write a Newton over an amp meter times a Coulomb squared over an amp Newton meter. Okay? Now I'd probably put the amp meter on the bottom. So it's like a Newton Coulomb squared over an amp meter and amp Newton meter. The newtons are going to cancel. You're going to have Coulomb squared over amp squared meters squared. And of course we know a Coulomb and an amp are connected. I is equal to Q over delta T. So an amp is equal to a Coulomb per second. So I'd be pretty tempted to say then a Coulomb is equal to an amp second. And then I would go over here and say, so then an amp second squared over an amp squared meter squared. So amp squared second squared over an amp squared meter squared. The amps will cancel, and I'm left with second squared over meter squared. Still doesn't tell me a lot, but it's like, if I took the square root of it, then I'd have seconds per meter. If I flipped it and took the square root, so remember it was mu o epsilon. So if we did 1 over and took the square root, we would end up with meters per second. So that number that you have in your calculator, flip it and take the square root. And did you? Flip it and take the square root. And if you do, you should get something like, my thing's in the way, something like 2.997999333 times 10 to the 8th meters per second. 2.9979. 2.9979 times 10 to the 8th. It's the speed of light in a vacuum. What's a vacuum? It's free space. Oh my goodness gracious. C is equal to 1 over mu o epsilon o. Somehow C is connected to magnetic fields and electric fields. Wait, maybe that's why it's called